Coefficient of variation. This is a very useful coefficient used to compare the degree of variation between two different populations. They can be really wildly different populations, and that's what we would need the coefficient of variation for. What we're going to do is do two examples. We have two data sets here. I'll show you the histogram of them first. So you can see that these two data sets have really radically different kinds of distributions. Data set number one has an extreme bimodal distribution, so we would expect quite a lot of variation in our measure of variation, a high degree of variation. Data set two is symmetric, where we'd expect less variation. In order to get our measures, we'll use our one var stats. I've entered dataset 1 into L1, and I've entered dataset 2 in L2. So we can see over here, I've already entered the data. So we can go stat, calc. Here's one var stats, and we can do one var stats for L1, and we have our mean is 34.65, and we'll use the sample standard deviation because we'll, I guess, assume that this is a sample instead of a population. Is 22.34. Now we'll go back and do one var stats for L2. And we have our mean is 359.05 and sample standard deviation of 117.62. Now you'll see that the units, and we don't know what the units are, but the magnitude of the measurements are quite different. This is in the tens, these are in the hundreds. So we can see the mean is much higher of a number than in the dataset 2 than dataset 1. Now the coefficient of variation, CV, is defined as the standard deviation over the mean times 100. It's a percent. So in this case, we're going to do 22.34 over 34.65. And what we get is 64.5% as our coefficient of variation. And what this is essentially meaning, it's comparing this measure of variation, this sample standard deviation, to the mean of this data that it's describing. So it's as a percent of the data's mean. And if we look at this one, we're going to do 117.62 over 359.05. And as a coefficient of variation, this is 32.8%. Now let's look at some of these numbers. First of all, in the data set that we would expect a greater degree of variation, we have our measure of variation being 22.34. In the data set that we would expect to have less degree of variation, we have a standard deviation, our measure of deviation is 117. If you kind of stopped and were just given those two numbers, you might conclude that data set 2 has the greater degree of variation because it's got the higher measure of variation. But you can see down here with the coefficient that in fact the coefficient of variation for dataset 2 is half of what it is for data set 1, right? Which is a better description. Comparing the two, we would expect this data set to show more variation than this data set. And the reason why the measures of variation, the standard deviation, doesn't really show that is that the measurements themselves are much higher in data set 2. And so the degree of variation is going to be just a bigger number because the numbers are bigger. Right? So this is why coefficient of variation is quite useful, because it sort of standardizes it. It compares the measure of variation to the mean of that sample. Right? So it's as a percentage of that mean. So really, this data set 1 has a greater degree of variation.